How can we learn from errors, and in particular, how can we use root cause analysis and the 8D process in order to learn from errors? My name is Helen Soulou. I'm a board member of the Get It Right initiative. I have worked in automotive, aerospace and infrastructure industries. I hold a master's in quality management and I'm a fellow of the Chartered Quality Institute. I'm also an honorary lecturer at UCL. And when I worked in the automotive in my early career in 2001, as a young quality professional, I got introduced to the 8D process. And tool set from Ford. I was working back then at Jaguar, and Jaguar was part of Ford, and they were rolling out company-wide training on the 8D. So a little bit about the history of the 8D. The 8D stands for 8 disciplines. It is in effect 8 steps, and it is a problem-solving tool that was developed at Ford Motor Company in the mid-80s. It started originally as with the original name of Team-Oriented Problem Solving Tool, and it was created upon senior management request. It is interesting that actually the senior management team at Ford realized that they needed a tool in order to solve problems as a team. And in the 1990s, Ford rewrote some of the material and called this tool Global 8D. In 1996, there was an incident, big incident, health and safety issue that happened with Ford and Firestone tires. They were exploding, and the explosions led to 271 deaths and 23 million of tires being recalled. And Ford used the 8D tool to investigate the issue. The investigation lasted a couple of years, and root cause was identified and resolved. The problem was resolved. And as a result, this became a very popular tool at Ford. I do remember actually being at Jaguar, there was an incident that we were doing an 8D investigation on, and it had a dedicated room and a dedicated team of people that were only working on the 8D. And it has become one of the most popular tools that is used today by a lot of industries to solve complex problems. Although we do refer to the 8D as a root cause analysis tool, it is used for containment of the problem, root cause analysis, and also prevention of the problem. So a little bit about prevention. I'll give you an example of how we've used the 8D and root cause analysis as a prevention mechanism at Heathrow. So in 2018, one of our directors had just become a director appointed responsible for health and safety, and we were having a discussion about our health and safety performance. Our health and safety performance was really good at Heathrow, but in order to actually take it one step further, we felt that we needed to do something more. And we discussed the fact that actually root cause analysis was probably going to give us the solution. Root cause analysis of incidents. So we asked all of our suppliers to accompany every first alert with root cause analysis using a standardized template. And one of the things that we actually did was we banned the word workmanship, and actually maybe I should say behavior as a reply. The reason for that is because somebody needs to look at why is poor workmanship, for example, the reason for an error, and why is poor behavior the reason for an error. So by doing that, asking for every first alert to actually have a root cause analysis, and also banning workmanship, and establishing a forum. We established a forum where we shared the learning amongst Heathrow designers and contractors. We were hoping that we would actually have even better performance on health and safety. And we also introduced a simple measure, safe days, which was as simple as that. How many consecutive safe days have we got in order to how many consecutive safe days have we got on site. In 2019, we also launched the quality and safety campaign, bringing our quality professionals together with our health and safety professionals. Quality professionals primarily were involved in facilitating the use of tools like the AT and root cause analysis, doing non-conformity analysis and investigations like that. And our health and safety professionals were actually learning how to do containment actions, root cause analysis and prevention. And in 2020, a contributory factor must have been all this work. We had our best ever safe day score of 293 consecutive days without an incident or a reader. One exceptional example that I would like to share with you before I move on to talk to you about the tool is the below. There was an incident that happened during a high pressure injection works to repair a crack in a concrete structure. A member of the team sustained a high pressure injection injury to the left thumb. So what happened was they injected resin into their left thumb, actually accidentally. And this led to the person having to have their tip of the thumb amputated and having to have extensive surgery. When the company looked into the root cause analysis for that incident, they identified that there was a design issue which allowed the system to remain under pressure whilst the person would lift the one hand in order to adjust the wall fitting. So they tried to prevent that problem by actually re-engineering the tool in order to eradicate the potential for this to happen again. So they've put controls in place so that when the operator would remove the one hand, the system would not be under pressure anymore. So the problem could not happen. The incident could never be repeated. Yes, of course, they did put operating procedures as well in place, but overall, by working on removing the problem from the tool set by design, they completely removed the potential of the incident to happen again. Moving on to the toolkit. So I'm going to share with you here some snapshots from the tool that we are using at Heathrow. And as I do that, as I discuss about that, I'm going to take you through the different steps. First step is to form the team. And we do record the team members at this page here at Heathrow, the front page. But forming the team is not a very simple thing to do. So first of all, AD cannot happen without a team. You need to have some core members, but you also need to be thinking about other disciplines that are going to help you, people that are going to bring you information, designers that may need to provide a design solution for an incident, for example. A team is a live thing, actually. It is something that is live during an AT process. You will have some core team members and people could join the team and leave the team as the AT progresses. Second step is to determine the problem. And one very good tool for that is the is and is not analysis. The is and is not analysis is something that I came across during my original training at Ford. It is very important because it helps you determine what the problem is, but also what the problem could be but is not. And it also asks you and takes you through different areas. So for example, who is affected by the problem, who could be affected by the problem but they are not, and who could be a person, or it could be a series of tools or joints or something like that. And then also what. So what is the problem? What is the type of the problem? What could the problem be but it is not? Why is the problem? Why is this a problem? Why is it not a problem? It makes you think about the parameters, that something is within spec, for example, or with outside of specification. When it makes you think about the time, when did the problem appear? When could it have appeared but it didn't? So makes you think of actually what are the different incidences that may have happened before an incident happened. And also a geography, where is the problem happening? So for example, is it happening in one building but not in another building? Is it happening in one type of joint but not in another type of joint? And how big is the problem, and how spread out is the problem, and how often? What is the trend? Is the problem diminishing or is it increasing? Was it an isolated incident, or is it a series of events that is happening? So very important to determine the problem correctly. And once you have done that, you are in a very good position to go into step 3, which is actually to understand the containment action that you need to put in place. So a lot of people, when an incident happens, want to jump into solution. But the reality is, if you get the right people and study the problem before you start, then you have a better understanding of the problem. You could, for example, originally think that there is one loose bolt in one joint, but actually you realize that it affects many joints, or it could potentially affect other joints. And then maybe your containment action needs to be more widespread. So a third step, after you have understood the problem, is verify the containment actions. And we have space here in our tool set where you can put down the actions and track actions, and make sure that people have gone and implemented some of the solutions that the team has discussed. When you have contained the problem, you know you're not producing any more problematic joints, assemblies, or a product. You know that you have contained any health and safety risks. That's when you actually focus on root cause analysis. Then the team can actually focus on root cause analysis without knowing that actually they have contained the problem. And you could use a lot of tools when you do root cause analysis. Some of the tools that we have here are brainstorming, the use of the boundary diagram, which is a systems a diagram where you can see links between other systems that may influence your problem. Cause and effect Fishbone diagram, which is the one that is here, so you can put as the effect the problem statement, have a workshop when people brainstorm potential causes around the facilities. So what in the facilities could have caused the problem? What in the methods used could have caused the problem? What is it around people that could have caused the problem? There are things like training, competencies, skills here. What is it about the materials, the machines, or the environment? So that gives you a structured way of thinking about potential root causes. Obviously, 5 whys. You can ask first a question about why is the problem happening. Then when people start brainstorming different ideas, you can ask further whys for all of them. And usually then you have a good indication about a series of events that have led into the problem. Obviously, data collection and analysis, maybe process mapping if you need to identify whether there were certain processes that happened or steps of a process that happened before the problem. Or if, for example, you have material from 2 factories and one factory clearly has a problem or not, maybe you want to go back and map the process of delivery of material into your site, for example. Is there something different that could be happening during transport operations? So all of these tools give you a good idea, and with the support of a good facilitator, you can actually start to understand the root cause of your problem. Then once you have identified potential root causes, these are all documented clearly. and we have a space here in our toolkit where we document them. You need to actually go and verify and evaluate these root causes, and usually you verify them against the is and is not analysis. So you can go back into your is and is not analysis, and you can see whether actually the root cause gives you a clear understanding why the problem has happened in the is column and why it hasn't happened in the is not column. And this is where you can actually test your root cause and make sure that it is actually the appropriate root cause. Another thing that you can do in order to verify root cause could be a simple test. You could go and try and repeat the problem. So put the conditions in place as per your root cause investigation and see if the problem is repeated. So put the conditions in place and make sure and monitor and see whether the joint becomes loose again, for example. When you have identified the root cause, that's when you know what your prevention and your corrective action needs to be. That's when actually you can go and implement the corrective action so that you can prevent the problem from happening. The example that I gave earlier with the pressurized toolkit was actually when they identified that the operation could happen, the system was under pressure only with one hand operation. That's when they knew how they could eliminate the problem completely. So at that point is when you know your permanent corrective action, and at that point you go and implement it. And the other thing that is good to be done is when you implement a permanent corrective action, you want to be removing the containment action that you have put in place at the very beginning. So if you had an inspection, for example, going on, and you have done something that now prevents the problem, there's no need to keep the inspection going. And also when you put the preventive action in place, the other thing that you can do is actually go and verify after a period of time that it is working. Preventive action goes in at one point in time, and then maybe after 6 months you go and do another inspection to see that everything is in order. So this is step 5 and 6. And hopefully after that you have actually contained the problem, and then all you need to do is actually share the learning through your learning forums or software or toolkits, or maybe you post your learning. Something that we do, for example, at Heathrow is we keep these forms filled in and we share them. We put them in our learning toolkit, and then recognize the efforts of the team. Obviously, it is very important that the team is recognized for what they have achieved, not only as a team on its own, but by senior leadership. It is very important to advertise all the good work that the team has done, so that the other teams can feel empowered to actually follow that. So that's it. Unfortunately, through this recorded presentation, we don't have opportunities for questions, but I'm hoping that we will be able to repeat the forum that we originally attempted to do today, and were not successful because of technical issues, and hopefully I can answer any more questions. Thank you.